Today we are checking how the functions calling process is simplified in LangChain. When you use a traditional LLM client, such as OpenAI, Mistral AI, and the other, you need first to create your function, and after that you need to document this function using this standard notation. You can see here, it just precise that the type is a function, there is the name of your function, the description, and you also need to document each parameter. So this is quite lengthy, and there is a better way of doing it in LangChain, even though they still accept this type of notation if you want to easily transition your application from a standard SDK to LangChain. However, the preferred approach in LangChain is to use a tool decorator on top of your function to automatically extract the docstring and the type hints from your function. So here we import from langchain.tools the tool decorator, and you see that I added it on top of my function. And also I added a docstring to my function. So instead of the full dictionary that we have seen above here, we can just document here in plain text what is the function about, what are the different arguments. It can also extract these type hints, and all together it will document the function. So this is the purpose of this decorator. It extracts the docstring and the type hints. Notice that if I delete the docstring and I just keep the simple function like this, it returns an error that it's mandatory to have a docstring when you use this tool decorator. So I will add it back. So let's go back here. As usual, I just add in a variable all the tools that I want to bind to my LLM client. And then I'm also creating a dictionary with all the tool names and the corresponding functions, so it will simplify for me when I need to find the correct function based on its name. So here there is a single one, but if there will be more, you will see the first function name, then the first function, and so on. The second key will be the second function name and the second function. So when we execute it, you see here that my tools registry, I've got this function, the name is adder, and then it extracts here this structured tool from LangChain. This is what you can see, that after you add this tool decorator, your function here, adder, is now not a function anymore. So when I execute this, you see that it has a different type of class. So this is a different object. This is more specifically a structured tool from LangChain. You can also, now that this is not a function anymore, you can extract as a property the description. So it extracts the docstring from your tool this way. The main consequence of this is that you cannot really run your function as you are used to. So if I will try now just to pass two numbers like this and try to execute it, you see that it does not work because this is not a Python function anymore. This is a structured tool, and this is not callable in this way. What you need to do instead is this notation that I wrote here and there. Maybe I should clear all the outputs, so there is a bit of surprise. And I will re-execute what we did so far. So when this is a tool, you need to invoke it. So once again, this LangChain consistency, whenever there is a runnable, you have this invoke method. And then you pass all the arguments as a dictionary. So if I try here, I provide that x is 5 and y is 8. It will return 13, just the sum of the two. Let's now try to bind it to the LLM client. So as we did in the previous video, you choose one LLM provider. I will choose Chat Mistral AI, and you load your environment variables to get your API key. This is how you can create your normal LLM client, exactly what we did in the previous videos. Additionally, we will create a second client. So I will call it LLM with tools, and I take my first client, and then I use the method bind tools to expose the tools to the LLM. So toolbox, if you remember, this is the list where we added all the tools that we've created. So here there is a single one, but it needs to be provided as a list. Now when you will invoke the LLM, you have the choice. You can invoke a LLM that has access to no tools, when you want to make sure, for example, that it does not rely on some of the tools, or you can use this one that has access to this tool documentation, so it is aware of the different tools that exist in your environment. But like functions calling, it will not execute them automatically. This will be the role of the agent that we will review in the next video. So I execute this, and now I've got these two LLM clients, and we will start a conversation. So as we did in the previous video, LangChain core messages, I will import the system message and human message. So in my memory list, I can start a conversation. You are a helpful assistant using tools to respond to questions, and then I'm asking a question that most very likely is supposed to use the tool that we created. And now when I create this response variable, you see I use this LLM with tools client because I want the LLM to use the tool that we created to respond to the question. But like a classic client that has access to no tools, this is still the invoke method, and you need to pass the list of all your messages. So we do this, and I would assume that the content of the response is blank, because like for functions calling, usually when they want to use some tool calls, there is no content. However, if you extract the tool calls from the response, there should be some. And indeed, there is a list, and then there is a dictionary for each tool call. We see in that case, there is a single tool call because we ask a simple addition, so a single one. And as usual, there is the name of the function it wants to run, the arguments that are provided here, the ID that we will need to pass in the response, and then the type is a tool call, as we know. So we will do like for functions calling now. We need to loop through these tool calls, and we need to extract the different arguments and add a tool message to the memory before we reinvoke the LLM. So far, we see already a few things that were easier if we compare with traditional functions calling. The first one was the creation of the tools. We just had to add this decorator instead of creating very long dictionaries. Secondly, to extract the tool calls, that was very easy. We just had to access the tool call property from the response. We didn't need this very long syntax like in the traditional SDKs, response.choices, index0.message.toolcalls. So that was another thing that was easier. And you see that here when I'm looping through the different tool calls in the list, so extracting the name, yeah, that's easy. That's just this key in the dictionary. The arguments, this is another simplification. When we did with Mistral AI, when we extracted the arguments, if you remember, that was not directly a dictionary, that was a string that contained the dictionary. So we had to use json.loads to convert the string back to a dictionary. Here, I can directly extract it. This is directly a dictionary, so extremely easy. The ID, as usual, we just extract the ID key. And now when I want to execute my function, just don't forget that this is not really a function anymore. This is a tool, which means that first I will try to locate my tool. So I'm using this tools registry that we created earlier. And based on the name, I can retrieve the corresponding tool. And this part retrieves my tool, which means that now I can invoke it. And if you remember, when you invoke a tool, you need to provide all the arguments as dictionary. Good news, this part is already a dictionary, so you can just give it here. You don't need, like before, the asterisk to explode your arguments. Here, you can directly provide it as it is. So extremely easy. Now that we've got the result of the tool execution, we can add it to the memory as a tool message. And as we did in the past, the content converted to a string to make sure you don't get any errors. Tool call ID, it's mandatory, so it can link this tool message back to the original tool call. And after that, if you want, you can also provide the name of the function that you used, but this is completely optional. We do this, and now we can reinvoke the LLM. So here, just to make sure, I will invoke the one that has access to the tools. if it wants to run additional tools, it shouldn't be necessary. But if you are 100% sure this is your final answer, it does not need tools anymore, you could also invoke the other LLM that has access to no tools. So it doesn't matter if you match. So if the first time you invoke it, this is the one with tools, and the second time, this is the one without tools. As long as you are working on the same memory, it shouldn't create any issues. So we reinvoke, and we add directly the response to the memory. And now let's look through all the messages and print them to see what happened. So we started with the system message, yeah, as expected. After that, human message, that was my question. Then we continue with the AI message that had no contents, but it had the tool call. And we see here, indeed, there are tool calls. It wants to run adder. This is the ID of the tool call. And we see the different arguments that it wants to use when we execute the tool. After that, this is the tool message that we created in the loop. It added the result to the calculation. And after that, we reinvoked the model, and it allowed our LLM to produce the final answer, telling us that based on this tool execution, the sum of 743 plus 999 is equal to 1742. So you can see that there were a few benefits using LangChain for this. Easier to define the tools, easier to extract the arguments, easier to extract even the tool calls from the responses. However, we still had to process manually then the tool within our loop. In the next video, when we create an agent, you will see that it will take it a step further, and it will also automate the execution of the tools. We'll still need to use that part. So what we learned here will still be applicable for the agent. We will still create the tools in the same way. However, the execution will be automated. And we see this in the next video. Bye-bye.